myself. I'm Mahor. I've been a software developer for about 5 years, and I was a compiler developer at an Estonian company for about 1 year. I'm a generalist, which means I worked on a wide variety of projects. For example, being the DevOps guy for the Swami server. I'll send you the links when I speak. I also make websites using the Mina stack, make native GUI application with Java and programmed microcontrollers with C and assembly, and many more. However, I decided to find my niche in Rust ecosystem, finally. These are the topics I'm going to talk about. First, I'll define what a compiler is and its structure. Then I'll explain why Rust is chosen. After that, I'll show you the basic Rust syntax. And finally, we'll build the compiler together. I assume you have some knowledge of a language like C, JavaScript, or Python to understand some of the Rust concepts. If you already know Rust, that would be great. You will have a much easier time. But if you don't, no problem. I'm not gonna use any complicated Rust concept, and I'll explain everything to the best of my abilities. So, what is a compiler? Some of you may not be familiar with the term. Simply put, a compiler is a program that translates code written in language into another. For example, compiling C and Java code into assembly and object code. If the target language is another high-level language, we usually call it a transpiler, like transpiling TypeScript to JavaScript. We can generalize the compiler structure into 3 stages. Each stage can have multiple phases and multiple intermediate representation. Each stage is for a specific task. For example, in the front end, we usually parse the language. Then we do semantic analyzing, and in the middle end, we do optimizations. In the back end, we usually just generate the code. And to keep this talk short, I've chosen a set of the TOM config format as the source language and YAML as the target. Obviously, they are not programming languages, but you could say that the process is similar. We don't need semantic analyzing and optimization, so our compiler won't have a middle end, as you can see in the picture. We don't need semantic analyzing and optimization, so our compiler won't have a middle. We'll have only a single IR, a parser at the front end, and a code generator as the back end. So why we chose Rust? I probably can talk about this for hours, but I'll only say that this language changes your view drastically, and it will make you a better developer, especially a better C or C++ developer, and you will appreciate a lot. Rust also has a great advantage for companies and teams because you don't need to worry about introducing memory bugs when working on a new code base, unlike C or C++. Rust is also being used in Linux, open source projects, in companies like Microsoft, Cloudflare, Discord, and DARPA. They are creating an AI-powered transpiler called Tractor to convert all C code to Rust. Rust is also a great choice for writing a compiler because the compiler should be both fast and correct. So I'm going to ask a question. How many of you know Rust? Please write 1 in the chat if you already know Rust, and 0 if you don't. So I can know if I'm going to cover the Rust syntax or not. Just write 0 and 1. Okay, thank you. We are going to cover it, so nobody knows Rust here.
Yes, generally Rust experience is 0 is used to generally Java and C.
Yes.
Yes, basic level.
So, give me a moment. Before that, before the syntax, let's just install Rust. Depending on your operating system and IDE, the process could vary. So I'm not going to cover it in the detail. Just go to the Rust website and click on the install, as you can see in the picture, and read the page. If you are on Arch Linux, refer to the Arch Wiki. After installing, you should have access to Cargo, which is the Rust package manager, and enter this command to create a new project. Cargo new, and we are going to name our project Tamr to Yam. Then open it with your ID and open the main.rs file in the source directory. If you open it, you will see this function which prints hello world. So this is our hello world program in Rust. It's very simple. If you already know C or C++, this should be very familiar to you. And yeah, I also highly recommend you to read the Rust book. Let me send the links in the chat. So this is the Rust website. This is the Rust book. And yeah, I highly recommend you start with this book. And we are going to cover the basics, the basic syntax very fast. So this is a immutable variable. Immutable means you cannot change it. You will receive a compilation error. So in Rust, everything is immutable, every variable, and this makes reasoning about the code much easier. For example, as you can see in the picture, if you try to change the x to another number, you will receive a compilation error, which says cannot mutate immutable variable. So if you want to have a mutable variable, you just add a mute keyword before x, and yeah, that's it. These are the primitive types of the Rust type system. So we have Boolean, char. Those should be familiar. We also have F32, F64, which are floating types. And we have I64, I32, and so on. They are signed integers. And we have U64, U32. They are unsigned integers. And we also have usize and isize, which the compiler will automatically choose a size for you, depending on the operating system and the hardware. So this is a struct. It is exactly like the C programming language. So no difference. It is also similar to classes in other languages like Python. You can implement methods on this type. This is an enum type, also known as a sum type. The struct was, we could also say, is a product type. They complement each other, and in the C, you usually use union keyword for it. So you also have sum type in C, but they are not as good as Rust. So in Rust, they are much better and easier to work with. We also have reference. It's exactly like C and C++ references, except that they are memory safe. And so the reference is that tiny character. I've written a red line under it. So we have also function, which is, and I don't think it's very complicated. We have parameters and the return type, very similar to functions in C. This is an example for how we can use a function in Rust. So here we first define two variables and also define their types in front of them. Then we just use the function, call the function, and at the end we are printing the results. We also have closures. So if you work with JavaScript or Python, it's similar to Lambda in Python or anonymous functions in JavaScript. So it's very useful and we are going to use them a lot. They are similar to functions, but they have different use cases. This is the control flow. A simple if-else. There's nothing crazy here. We have for loops, and the for loops in Rust are similar to Python. The syntax is very similar, so you don't need to manually count the iterator like you do in C or C++. We also have pattern matching, which is very powerful. Like you can do something like this. So if you can put your conditions in the match Rs, and Rust will automatically match them for you. So it's very powerful. You can do something like this. So if the number is from 1 to 5, we can use something like this, or we can even match on the objects. So we have an object called point here, and we are matching on different points and printing a different text depending on the values defined in the point. So please ask if you have any questions. Was my talk clear for you?
Yeah, it was.
Sure. So let's go to intermediate representation. We first create a file called ir.rs. So our source tree looks like this. Then we link it in the main.rs. I'll also open my editor later. I'm just covering these using my slides. Then I'll open my editor then we can experiment. We want a data structure that can hold all of the data we need. So for the intermediate representation, to do that, look at the source language and split it into its building blocks. So for example, in the official TOML website, it has a very good example. Here we can see tables and key value pairs. And this, for example, this is a key value. All of it is key value pairs, and we want to start with the smallest building block, like maybe a key. For example, title is a key, we want to start from there, and we write it in a Rust like this. So this is called a new type. It's like giving a new meaning to another type. New types are zero cost, meaning there is no performance hit. Unlike in other languages like Python or JavaScript. The reason we are doing this is that a string can be anything, like maybe a book. You could store a book in a string, but what you want here is we want our string to follow a specific rules defined by the TOM specification. To ensure this, we can use new types. This is also a new type, different style, and if you don't like the tuple syntax, you can use the struct syntax. No difference between them. And you can access the inner type directly if it's public. So if you use the pub keyword, the field is public and you can access it directly. And if it's private, you cannot access it directly, and you need to implement methods or traits on the structure. So, for example, this is a public example. The object dot and zero characters. And this is an example if the string wasn't public. So to creating the object, you had to use a method called new. And yeah, also you also have to another method to accessing the might forget small details and make mistakes, like passing a wrong the identifier to write unit tests. But why you do that when the compiler can catch your mistakes? If you work with a large project in Python without proper testing, you know how painful it is to add new features or fix bugs. Compiler-driven development. So now let's talk about values. We've created the key structure. Then we are going to create enumeration value. As you can see here, a value can be different types: strings, integers, floats, booleans, arrays, and inline tables. To see all possible values, we should refer to the TOM specification, and it covers all of it. But the number of types is limited. So using a Rust enum is a good choice to represent these values. Here's how we can model it using a Rust enum. So this data structure can either be an integer, a float, a boolean, a string, or and it cannot be all of them at the same time. So just one type at a time. So this is the power of enums in Rust. You can put types in the enum kinds. So than a certain number. So we can use these primitive types to represent our integer value and float value. And yeah, that's it. Let's go to the array. So as you can see in here, array can store values in itself. It can also be different types in an array. So, for example, in the data key, we have arrays inside another array. So, to model it, we use another new type that holds a vector of values. A vector is also a list if you work with Python. It's similar to that. And yeah, this is where I put the array type. Then we'll go to the inline table, which is temp targets. It has key value pairs. A pair is just a structure with two fields, key and value. We also have an inline table, which is again another new type. Tables. So we also have tables alongside pair and values. A table is just have a header and body. Also, a table is just an inline table with a name. So we reuse the inline table type in our table structure. Then, yeah, that's it. Now let's look at the whole document. Our whole document is just a list of tables. Just a table without a name, a table named owner, then a table named database. Sorry. So we model it like this, a vector of table. This is our whole document. And our intermediate representation will look like this. This is our whole data structure. So now let's go to parsing. First, again, we'll create a new file called parser.rs. And we link it in the main.rs file using the mod keyword. Then I'm going to use a crate or library called num, which is an amazing library for parsing strings. So also we are using Insta. Insta is another crate which helps us to test our code. So we add them using cargo add num and cargo add dev Insta. So because we don't need Insta for the compilation, for the it's going to be only used in development time, so we don't need to add it into a dependency. And yeah, the rest I'm going to cover it in my editor. So please let me open my editor. Okay. So I've created the parser functions before the presentation, so because it's very time consuming to make this, and we don't have a lot of time. Let me make it bigger. So these are just imports. We are just importing types and functions from the num crate. Also, if you look at our cargo tom, we can see we have num as a dependency and insta as a dev dependency, and for parsing, for starting parsing, we are going to start from the smallest building blocks, which is a float. Let me find this. So the simplest one is just a float, this number right here. We can parse it like this. So this is a function that accepts a string and returns the remaining strings and the parsed float type. So, and how we know which function we should use? We just go to the num page. In here, there is a link, list of combinators and their behavior. Can open this, and so here we can see all of the useful functions of num, and we don't need to learn all of it. We just need to know which kind of function we have. So, for example, these functions are like if, they are like if they try a list of parsers and return the result of the first successful one. And these are basics, and we have sequence combinators, which are like for loops. So if you want to have a list, you can use them, and many more. So I'm not going to cover them right now. We'll go step by step. So for float, I've just searched float here, and this function comes up. And we can open the documentation, which is very nice. The Rust case usually have very nice documentation in a they are very clear compared to C and C++ documentation. They are very messy. I hate them. And yeah, for floats, it can also support this kind of scientific notation. So because let me open the Tom language. Oh, it's here. If we open the specification and float, yep. So in Tom, we can also have this kind of values, which are scientific notation. And num already supports parsing them. So we simply use the function, and that's it. Let me also show you the example of how I use it. So this is our test cases. So this is our function. I just passed a string called which looks like a float, and unwrap it, because in Rust we have results which are like try and catch in other languages, but result it's better. You can know all of the error values that you can get. For example, open this type, see that it's another result which looks like this. It's an enum. our function returns the error. So let me show you like this parse float. For example, we can use the match to differentiate between them. So if it's a OK variant, we will have a string float, and if it's a and for example prints the error, like, or we can use the return value. We can also do something like this, for example. It's very useful. Is remaining str parsed str. So this is a float. We can then print it, for example.
Oh, sorry, Mahor. You can control
Yes.
the internet connection, and sometimes close your screen and not connections.
Does my sound did I disconnect for a moment?
Yes, for your microphone and camera and screen and not connections sometimes.
Oh, okay. So I've connected to my phone.
We are
So
control our friends and we are no problem with our internet connections.
let me close my camera, so maybe it helps.
Okay.
Okay, parsed still. So let's now we can run this test like this: cargo test, parse float one, and let me see. So remaining str is oh. Right here. So I don't see it. Oh, it doesn't have a 0. Okay. It doesn't show the printing value if parse so that's working correctly. We can also use these. Yep, it shows. So I reverse all of it. Yeah, okay, that's it. This is our first function. Then we parse another type. So for example, Boolean. A Boolean could be a true or false value. And we use tag. So tag is a function. Let me show the documentation. So tag, yeah, recognizes a specific suite of characters or bytes. So whatever we put here, this parcel will succeed if this string is also looks like that. So if it looks like a true, it will succeed. If it looks like a false, again, it will succeed. And then we map the result. Oh, sorry, before that, we use alt, which is like a if-else, to combine these two parses together. Then this function returns a result. We can map the result using map, which is a string. So we want to map it to a Boolean. So we again match on the string, which can look like a true, which is can only be true or false and not anything else. So we use the unreachable macro to just say that to other developers that this arm is not reachable. And that's it. So we return true and false, and then we call parse to call all of these parses together. So this is our Boolean function. You can also, yeah, I'll show you the test cases. So we call it parse Boolean and parse true. It succeeds. But if you call anything else, for example, other, we get an error. When we can unwrap error to check for the test. So, okay, if you have any question, please ask me. So I'm not sure if I'm if I'm teaching what I'm teaching, you get it or not. So. And yeah, the rest is the same. So we have a parser for integer. It's here. And then we have a parser for a string, parser for array, up to the it could be alphanumeric, so it can consider of these high small characters. So we also parse that like this. So you can see I'll put the source code later, so you can watch it for yourself, check it out for yourself. Then we parse the pair, then the inline table, then we parse the value. It's just an alt, and we alternate between parsers of the different types. And this is all the parse value function does. Then we go to the table. We again parse it to get the table. Then we parse the whole document, which is, as if you remember correctly, is just a document, a vector of tables. So we also use the fold many, which fold many function, which was this sequence. Yeah, it's a sequence combinator. No, it's similar to a sequence combinator. At the end, I just created a parse function that maps the result type to a type that I like. So we will have a document and a num arrow. This is our whole parser. And then we create a file called generator and link it again into our main function. And here it's easier. We just implement the display trait for our types. First, we start with the identifier, which is the easiest. We just call the string format on it. So this function is going to print the identifier like a string. Then we implement display for value. Again, these have a lot of
Oh, sorry, Mahor.
inline table. So as I was saying, we just implement display trait for each of our types. So it's a lot of code. But I can show you what each one of them do. So let me write a new test. Fn test something. And for example, let's create an array. So we've imported it. I'm creating a new vector of value. To import value. A value of a string, for example. So we created an array. So what this trait does, let me show it. I'll disable it. Then, so I'll go here. What this trait does is that it implements a function that can be used to print our array. So it can be like this. So if we don't implement it, we will get a compilation error. But if we re-enable this trait, we can print the array like this. And we will print the array in a way that it looks like a YAML format. So let me add another value to this. For example, this time a float. So let me add another one. Integer. So this is our array, and let me call the. So I think. Do you hear my sound?
Yes.
Okay, thank you.
Kübra konuşabilirsin bu arada da oradan.
So let me call this function.
Ben ses gelmiyordu. Onun için biraz kötü oldu.
So as we can see, we've printed our array like this. It's in a YAML format. So if we look at YAML, let me call YAML website. if somebody hasn't seen the YAML format before, it looks like this. It's usually used in Python projects. And this is an array. This is a table. This is a string, for example. So it looks similar to TOM, but it's still very different. So yeah, we just implement the display trait for each type, and we just try to format our type in a way that represents, looks like a YAML format. And I didn't, for example, I didn't write all of this in one go. I iterate on it. So I first started from the identifier, then I I've implemented display for value. Then yeah, it takes time. So for example, a few hours, but at the end of the day, you can see how your compiler works. So I'm sending this our parse function, our TOM, which looks like this. Or let me open this. So this is our TOM test. We are testing this file, and we send it to our parse function. So our parse function converts this string to an object called document. Then we convert the document to a string again, but this string looks like a TOM, looks like YAML. Sorry, it looks like a YAML format, and yeah. So we can also call this program. If we go to the main function, we can use the std env args function to accept argument from terminal. Let me write it again. So show it to you. We can std env args. So this function returns the arguments from the terminal. Then it returns an iterator. So we can call the env function on it. For example, we want the first parameter to this program. We want to get the first parameter, and we can store it in this variable. As you can see, it's an option of a string. So an option is just an enum. So let me go to the definition. It's just again an enumeration of none or some. So what it tells us that this variable can either contain a string or contain nothing. It's an option, but usually biggest mistake programming industry or development industry. I don't remember. Match value. It's not be some. It's some. First are created so we can how to run this. I want to run it and pass it my pass file to my program. To do that, like this. So here, I want to operate first. This. Let me stop. So
Mahor, can you hear me?
yes, yes.
Yes. And I would like to inform you that we are approaching in the out after our meeting, and our next season is just around the corner. Ben mi görmüyorum? Mahor, can you hear me?
Can you hear me?
Yes.
Okay, I was disconnected.
Okay. What time is your presentation?
It should be. So I think. Hello.
Yes. You hear me?
Oh, okay. Yes.
Yes. I would like to. We are approaching end of our meeting, and next season just around the corner.
Oh, and we have our compiler. This is. We are passing our test time, and we are getting a YAML format. This is our compiler, and yeah, thank you for your time. Let me unshare.
Okay. Thank you for presentation and for examples, Mahor. Thank you for me, Mahor.
You're welcome.
Can answers your question? Do you have any question, members?
I have one.
Okay.
What are the most practical applications of integrated deep learning in real life?
So I haven't worked in the deep learning field. There was a miscommunication between the Dev Codex team, which I said to them I worked on interface descriptive languages, a compiler for interface descriptive languages like protocol buffer in the Google company. So I don't know.
Oh, okay, thanks.